very much happy to announce those two nice gentlemen you see in their wonderful, colorful jackets in front of you. These are my dear colleagues, Wilfried Sommer and Dirk Rohde. Both of them are professors at Alanus University, and they are in the faculty for the natural sciences. And I like to introduce Dirk Rohde first. He is a long-time Waldorf teacher at the Marburg Waldorf School. Right now, he is retired. He has a doctorate from 2003, and this is about what is the meaning of lively teaching. And then what I really admire him for, that he also has achieved the opportunity to do a habilitation. This is a special German academic qualification which comes after the doctorate. It's the next step, some kind of another doctorate, and he has that in the field for the topic, how do Waldorf students cope with the demands of centralized final high school exams? So there he has done an empirical overview about the performance of Waldorf students in relation to the final exams. And right now he is a professor at Alanus University. His field of teaching is mainly from school biology, but he covers everything around classroom performance, teaching methods, and often teaches at Alanus University. I'm very much happy you are here today, Dirk. And this year we had a special experience. We have been teaching together in Chengdu, in China, and have given there a course for the Chinese Waldorf movement. And I also am very happy to welcome my dear friend and colleague, Wilfried Sommer. Wilfried Sommer is also professor at Alanus University. He is also representative and responsible for the Kassel teacher training center. He will will show us that there will be a big event in springtime next year, International High School Teacher Training, which takes place in Kassel. Wilfried Sommer has a doctorate in the phenomenology of physics, and he is also for this subject, he is a professor at Alanus University for the phenomenology of physics. And both of them, they do a, so to speak, a double lecture, which shows that they did a pilot project for around the topic the atom. And this pilot project is about a hybrid high school teaching period. And I think this, when we speak about what can we do better, of course, the question of digitalization, is hybrid teaching by any chance something we want to have in a Waldorf school? And they did it from two angles, from the angles of physics and from the angles of chemistry, as far as I remember. Please correct me. And they will present that new format. They did high school teaching in connection from Kassel and Marburg Waldorf schools. I'm very much happy you are here, and the stage is yours.
Thank you so much, Joost.
Thanks a lot. So,
And
we'll take over the first part.
and Dirk will continue in the second part, and I would like to express a warm welcome to everybody. We are here in the Institute for Subject-Related Methodology in Kassel. It's an institute closely affiliated to Alanus University, and we are under the same umbrella like the Teacher Training College in Kassel, and we have a strong cooperation there. And in this room here, it's the room for science education. Both teacher trainees and Steiner Waldorf students are taught in this room. And just to get an impression, that's the situation where Dirk is seated beside me. In the back, there is a student of our teacher training college, and here is the screen with the PowerPoint. And you can see that we can just move it a little bit. And the topic of today is the atom contextual approach, pilot project hybrid high school teaching. And the series of lectures offered by the International Campus Waldorf is what can we do better? The challenge of transformation in Waldorf education. And we would like to add something for today's lecture. And our main concern is the challenge of a sustainable relationship with the earth. And we have the impression that Steiner Waldorf education can contribute through the way of forming judgments, especially in science education, that Steiner Waldorf education can contribute to this challenge. And so I would like to add here the challenge of a sustainable relationship with the earth. And both of us, Dirk and I myself, have the impression that Steiner Waldorf education can contribute something to those challenges that we face as a society at the moment. And our endeavor really is to contribute something where Steiner Waldorf education offers some perspectives to form judgments in a new way. And as an introduction, I would like to look at the science curriculum very briefly. And the science curriculum in Steiner Waldorf schools has in its main center an approach which can be denoted as doing phenomenology. So the approach in Steiner Waldorf education is doing phenomenology. And that means that you strive to provide a shared encounter in class where a series of experiments is presented that can be demonstrations, that can be hands-on by the students themselves. And in this series of demonstrations or hands-on experiments, the students can experience that in those appearances, some symbolic forms, some explanations are already implicitly present. And then in the next step, they try to figure out how the laws of physics can be discovered, how the implicit can be made explicit. And so teachers are trained in doing phenomenology really to perform experiments in a way that it is like performance art evoking insight here. And that has to be shown in detail. And I would like to contrast this approach here with the mainstream approach. And in the mainstream approach, you have a lot of schools where a reductionist approach is predominantly taught. Reductionist approach. And in the reductionist approach, you really try to reduce some structures out of the experiments, and you try to reduce or to find those structures that can provide an explanation. So the wonderful moment in the reductionist approach is that you can really provide explanations in a quite easy way. But to reduce something means that you start thinking in a way like nothing but. Matter is nothing but a collection of atoms. A solid is nothing but a regular or irregular order of more or less fixed atoms. A gas is nothing but moving atoms or molecules, and if they have an impact on the walls, if they have an exchange of momentum at the walls, you have pressure. So it's a way to find explanations in a quite easy way, but the disadvantage is that you look at nature like a TV viewer or TV watcher. You become a spectator and you just look that nothing but the atoms do something. And the striving in Steiner-Waldorf schools is to take the appearances seriously. And if you take them seriously, to find symbolic forms within the appearances that provide an explanation. And what was missing for a long time is something like a connection between the two approaches. And for a long time, predominantly Steiner-Waldorf teachers or Steiner just criticized the reductionist approach. But then the question was always, if you have a phenomenological approach, what can you say about the atom? And what we are looking for is that you have a not merely reductionist approach to connect both doing phenomenology and the reductionist approach. So what we are looking at is not merely a reductionist approach. And I remember 2 or 3 years ago in Alanus, there was a lecture of Helmut Zander, and it was a seminar offered by Joost. And I remember at the very end, we asked Zander, what would you think is an approach of Steiner-Waldorf education that is something unique and where Steiner-Waldorf education can really contribute to something? And Zander answered, Steiner-Waldorf education is a not reductionist approach. And because I'm a little bit careful and learn to be careful, I put it, it's a not merely reductionist approach to avoid this discussion how much reduced reductionism is within the symbolic forms in this approach. That is just the content. And now I'm looking at the timeline through the development from a student in a Steiner-Waldorf school from grade 6 to grade 12. And if you look at the science education starting at grade 6, for a long time, we really had a phenomenological approach from grade 6 to 10. And in grade 11, there were serious challenges to provide a phenomenological approach to electricity. But thanks to the activity of a lot of people, and especially of Florian Schulz or Johannes Kühl and others, there were proposals how to introduce electricity phenomenologically in grade 11. And I think we can, the state of the art at the moment is that we really have from grade 6 to grade 11 a phenomenological approach. And phenomenological approach means there is math, there is geometry within. It's not just nice, but the symbolic forms for explanations are closely connected to the appearances themselves. And then for a long time, there has been like a crack or a ridge or a gap here. And then in grade 12 and especially in 13, the preparation for the university entrance exams was taught in the mere reductionist approach. University entrance exams. So the gap was for the students at the Steiner Waldorf schools, there is a huge gap. Up until grade 11, there was one approach, and here it was the mere reductionist approach, and that was the content for the university entrance exams. And the problem was that we had no phenomenological approach to the atom. And I think that gap can be bridged. Now we have it, and I will just sketch it very briefly in a couple of minutes. And then at some time, Johannes Kuhl found a phenomenological approach or a specific approach to the electron. And later I developed it for the atom. And then we could bridge that gap, but there was no time left where we were able to teach it. Why? Because the curriculum for the students is that tight in grade 11 and 12 that there was no chance, and you really need the main lessons. They are structured quite well. You need them from grade 6 to 12 just to teach physics in an ordered way. And just to bridge that gap, there was no chance, and there were no place in the schedule where it could be taught. And so we had a lot of discussions, and after some time we said, okay, let's try it with an elective. And because we really can contribute something to the situation that we can build up a sustainable relationship with the Earth, but then we have to introduce electives to bridge this gap. So we have two aspects here. One is the elective to bridge that gap, and the other is that we look from a phenomenological approach to the reductionist perspective this way. And Dirk and I myself had a long exchange on that, and then we decided let's try it in an elective. And we started this elective after some first experiments in the school year 21-22. We started this elective in the school year 23-24. And now I'm going to present a little bit on this elective. You see here the atom, that is the contextual approach, is the not merely reductionist approach. The hybrid high school teaching is we try to offer this elective in a way that it was taught at the same time in Kassel and in Marburg. And here in the background, you have an ink drawing about some structures you find here. And it's an ink drawing because I was able to develop some of these ideas during I taught in Beijing and the Chinese culture. And the Chinese environment was really crucial for being able to develop this. But of course, in the progression of the teaching, this Chinese situation changed in a very formal situation where you have systems of reference here, where you have one-dimensional diagrams here of field structures in the environment. And now, what about the hybrid high school teaching? Here is Kassel. It's a brief drawing about it. Here in the first floor is our lab. We are staying here at the moment, and this is Dirk's arm teaching in Marburg. And so what we actually, now we are entering the room here. Here's the stairways, and in here we are. Here's the early childhood education. I meet a lot of funny people there. It's really nice and cute. And then we enter the hybrid high school teaching, and we start that Chris taught in Kassel, and it is transmitted to Marburg. And we did it for 4 hours a week. And the physics was for a quarter of a school year, from fall to Christmas. I taught here physics, and I had in front of me students of the Steiner Waldorf School in Kassel, 11th graders, and here in Marburg were other 11th graders. And during I taught here, it was submitted to Marburg. And we structured the lessons in a way that we had lecture components and about 10 to 15 minutes. And that was followed by an individual work or group work. And in the first part, students could ask questions, and then they were transmitted from Kassel to Marburg or Marburg to Kassel. And then the cameras were switched off, the microphones were switched off, and the students could work individually, and they were accompanied and supported by a person teacher in Marburg or Kassel. And then we had a collection of results, and that was continued several times. And here is the other way around. From Christmas to Easter, Dirk taught chemistry in Marburg, and then it was transmitted to Kassel. And in Kassel, I was the lecturer or teacher accompanying it. And during Dirk presented something, beside the huge screen you are looking at the moment, I had a flip chart and I took notes, so the students were able really to see how I took notes. And so they had the idea of Dirk's presentation of my notes, and then they could decide how to take their notes. And at the very beginning, I had a refugee in my class, and so I decided to teach in English because his English was quite good, but his German had to develop, and the students pretty much liked that. And so the very beginning was in English. Okay, that is the setting. So half a school year, 4 hours a week. Half the time physics, half the time of that chemistry. What are the lessons learned of that hybrid teaching? We have learned 2 new words, the roomies and the zoomies. We learned that in the literature. And on site you have the roomies, and so it was of prior importance that as a teacher you really use the blackboard. And if the students on site, the roomies, really have to take notes or just work with worksheets afterwards, really depended on the content. But the zoomies, the remote students, it was really important that the teacher accompanying it or the lecturer takes notes, and that his taking notes is visible for the students. So the students were accompanied in their learning pathway, and the result was that the students pretty much liked this atmosphere of common learning. And our really good experience with choosing English as the language to teach this elective, we have the proposal to use that setup for global learning. In December, on Research on Steiner Education in this journal, an article will be published, and the reviewer asked us always, or asked us, can you tell me what is the use of the media here? Is it something really new or not? And then you have certain categories that are discussed in the community. Do you have an augmentation, or do you have just a substitution, and so on? And for us, it was a substitution here, of course. We had some modification for the lecturer for the zoomies, and we had some sort of augmentation, but nevertheless, we do not look at it as something where the media is used in a brand new way. We have the impression the media is just a tool here. Why? Because it was the only chance for us really to teach chemistry and physics together. But we used it as a tool and not, in our impression, in a brand new way. So these were the lessons learned here. And now I'm continuing to some aspects related to the content. Relating to the content and to the atom, it is a matter of course that I cannot explain everything now, because that would be hard, yes, 4 hours a week for a quarter of a school year. But the aim was really not to look at matter as nothing but a collection of atoms, and appearances nothing but the interaction of atoms. We had another idea. We looked at the atom as an element of a description and not as an instance of explanation. And that was our main concern. Not because the atoms are doing this or that, we have this or that appearance, but we just looked, if we have this appearance and we would like to describe it in a local way, and in a local way that is within an additive context, then the atom has to be conceptualized this way. So the idea is you look at the appearances, and the atom is a local way of describing the appearances. And then at the very end, the students were able, for example, to say, okay, the atom is a concept and form of matter in which a localized elementary charge has a certain energy, and the energy describes the interaction potential with the environment. So you have the localized charge and the environment in one sentence included, and you have two aspects. Something is localized and it has its environment. And you have something like a center and a whole area around the center. And in this approach, both aspects had to be brought together in every moment. So this was our pedagogical aim. And when we did it, I realized, for example, that I really had to relate to matter in a very basic way, because at the very beginning, students had just these mental pictures of atom as a pre-concept in them. And then we just looked at the situation of matter and space. And if you do this in a phenomenological way, you realize that as a toddler in a cradle, you are just there. You take up space as a matter of course. Then you can become upright, and then you start to take up space in a very specific way. And all these appearances are brought together in that mental picture of the three-dimensional space. And this was about 2 or 3 hours in school, and I did it step by step. So matter and space are an experience of self-efficacy as a small child. You are just there, here you are. Then you move your arms, you conquer your space, then you stand up, then you balance your uprightness here, and then you form this mental picture. So space and matter were developed out of bodily experiences, and then we related that to grade 10 mechanics, and I'm not going to go into detail. You can see here that's the rare blackboard, and optional, you can use the front blackboard to do it mathematically. The main idea is you have a state where a card is. You move it uphill. That is an interaction with the earth. Then it is in a new state here and has the potential for new experience. For example, through the interaction with the Earth being accelerated, and then you get a state of motion here. And this, which is state-of-the-art physics, grade 10, introduction of energy, and then that is new, can be brought into this diagram here where you have two states. These are the red lines and the interaction processes that describe what is happening through, through the gravitational interaction here. So you have states and interaction in this diagram. You just denote it this way. And then you can just compare that. Here it is uphill and downhill, the mechanical realm, here's the electrical realm. And in electricity, in a phenomenological approach, charges are the quantities that are related, where electricity is tied to matter, and fields in the environment are a structure in the room without matter. And if you look at symbols like here, systems like here, you find the same symbolic forms. And for me, I only show it here that you see you get the same symbolic forms here in mechanics and in electrical systems. And if you continue that and you have localized charge, and that is the very end then of the curriculum, you have elementary charge with a certain energy that are denoted here this way. And you have mutually dependent electric and magnetic fields. And this interdependency of fields here propagates with light velocity. So you have in the center the potential of the energy here. And at the same time, you have in the surroundings mutually dependent fields. So in the atom, you combine the possibility of certain appearances and the structure in the environment at the same time. And that was something what I actually was able to develop during this teaching. And the idea was to show the students that even if you look at the atom, you have a center and an environment. And that was really, I was delighted to find by looking at the atom, at these very tiny objects, to find in the same moment that how it is connected to the whole environment. The students experienced it this way, that they saw, when they reviewed the elective, they told us, okay, we had in our chemistry block the popular approach, and in the elective, we had a really scientific approach. So that was their experience, because it was a phenomenological and philosophical approach. And my aim is to really appreciate also the reductionist approach, but as a Steiner-Waldorf students, to have a not merely reductionist approach available, where you can really bring together with the university and entrance exams a broader perspective. You do not just combine with the atom's agency, but what you really bring together with the atoms is a broader perspective where you can see the environment belongs to this object atom. And that was the interesting point. And the book that will be launched in Hyderabad in January about the atom and the contextual approach to the atom, this book will underline or offer an approach where you can have broader experience in the Steiner-Waldorf curriculum, and you can apply it to the exams of the university, to the university entrance exams, so you have a broader perspective. That is my main concern. So it's not in opposition to, but it is like an add-on or an additional offer to bring a broader perspective. And my personal conviction is that through that broader perspective, you do not have only a reductionist view at the atom, but you have a view that can build up a sustainable relationship. And so far for the physics part. And now, of course, I have to clean my Blackboard. And during I'm going to clean my Blackboard, you get the advertising block. And this is our conference that will take place the week before Easter. It is a cooperation of the Federation of Steiner Waldorf Schools in Germany, of the pedagogical section, and our institution. And where we will offer a lot of subject-related methodology courses, and the conference language will be both English and German, and there will be some additional courses in Spanish offered by Constanza as well. And in this conference, of course, we have a topic that is like the overarching theme for everything, and that is, if you're here, understanding is translating. Teaching is a process of translation. And I just leave it for a moment that you can just read it. And I have to continue to clean the second Blackboard for Dirk. And then he will continue. It's like switching from Kassel to Marburg, but it's in the same room at the moment. And now Dirk will continue.
Okay, so yeah, hello everybody. And Wilfried explained already many things about our hybrid teaching, and I only want to add one thing you might ask. So why did Wilfried not look for a chemist to teach physics and chemistry block only in Kassel, or me myself looking for somebody who is able to teach physics, teaching both subjects in Marburg? And the thing is, there are some more points behind our main idea, so to say, because actually we face a lack of teachers in at least in many German Waldorf schools, but I think, like we heard last week, I think it's true for more or less all Waldorf schools all over the world. So actually, here in Kassel, there was no chemist able to teach the chemical part of the atom of this block, so to say, block teaching or elective teaching, and the same in Marburg. And so our idea behind it is also, when Wilfried teaches here, for example, in Kassel, there could also some students could sit in this room and as well could follow his teaching in other schools and learn by just observing him and following him, learning how to teach this approach to physics, to the atom, to the electron. And by this, we could also do something for teacher education, vice versa for chemistry, and this is true for all subjects. So our idea is not only it's not concentrated only on the atom, and not only on physics and chemistry, but it's more a broad idea of doing something for teacher training all over the world, since with this sort of media, we can, all schools worldwide could join this. Of course, you have to find a reasonable time for this, and due to the different time zones and so on. But it could be done worldwide. And so this is something I would like to emphasize on right at the beginning. So Wilfried talked quite a bit about the whole thing, so to say, and I want to give you one idea and I want to introduce you into one of these lectures I taught on chemistry. This is just one example for you that you get into the approach a little deeper and into the way of thinking we train in from our perspective in Waldorf schools, because this is very important from our point of view, that Waldorf education is more a question of method rather than of content. And method means, in this case here, it's a special way of training how to think in an appropriate way about very specific questions. So how did I start the chemistry part? Now I need here, and can you switch it? Yeah, I'm seeing here now. Yeah, on the screen, fine. So see, now here you see the German and here the English translation. I started with the key question to get the students right into the thinking process and then to make clear that the atom is, on one hand, is a scientific term, so to say, or it's important for science on one side, but on the other hand, it's also an important part of philosophy. It's an idea. On one hand, it's something you can see or you can work with. On one hand, on the other hand, it's an idea. So in the beginning, I asked the students, what does it mean for your thinking if you assume that matter is made up of smallest building blocks? See, this is what I wanted to encourage the students right in the beginning, to keep this question in mind. And then all during the weeks, sometimes I came back to this question, and in the end, we discussed it then after we had learned quite a bit from the physics point of view and from the chemistry point of view about this question. What does it mean for your thinking? So why is it important from my point of view? Can you switch it again, Wilfried? See, when you have the term atom, see, atom means A, this is a Greek word, and A means not, or it's a negation. And tom stems from tomain, that means to cut, to separate, to split. So the word here means this is something you cannot split, you cannot divide anymore. That's the idea of this word. Of course, all of us know today that no serious scientist would say an atom cannot be divided. All of you know that we have like atomic power plants and so on. But this is the original idea. We'll come back to this in a second. And then you see, when you look onto the Latin language, you have another word. This is individual. And in is the same like A in Greek. And so this meant divide. So this means, well, all of you know what we mean when we say individuum, but the word actually means the very same. See, this is a personal point of view. It's something when you look onto human beings, you talk about individuum and individuum, and human beings call themselves individual persons as well. And atom seems to belong only to science on one hand, but on the other hand, it relates very closely to each other. The idea of atom and the idea of individuum belong to each other. And then, please, next slide here. One more, please.
You have it already. Next slide.
Yeah, this is the English translation. I left the German, but yeah, this is here. See what you know, that the word atom and so on stems from, like, we related to Greek philosophy, but it's also found in Indian philosophy. I thought this is a nice idea because it's here. It's very nicely described. It's Indian philosophy, and it's about 2000 years or maybe even a little bit older. So what is it said in Sanskrit, of course? If you divide something, this division goes as far as to the atom. And we speak of the atom, which was called paramanu. I don't know, I don't speak Sanskrit, but something like this, which means extremely small, because the sequence of getting to smaller and smaller things by division comes to an end here, as there's nothing smaller left. If we divide a lump of earth into its parts, what follows becomes smaller and smaller. So as you can easily see here, it's a way of thinking. And I will demonstrate it for you, and I think this should work. Like when I decided not to take a lump of earth to keep my fingers clean here, but like here, if you take a lump of cotton wool, for example, yeah, this should work here, and then I can divide it into two parts, and I can divide it again and again, and so on. I can go on for many divisions, and the idea is that there must be some point that you cannot divide it anymore. And this is just an idea. It's not, you cannot prove that. It's just that you think there must be a smallest portion, and then you cannot divide it anymore. I want to introduce you now into how I work with this idea in my teaching in chemistry. So first we need the blackboard. You might know this reaction when we make or when we create water, so to say, we need 2 volumes of hydrogen plus 1 volume of oxygen, and then we get, and I leave this here blank for purpose, then you get H2O. That means water. So we are talking about volumes. And so for this purpose, what I do is I take some sort of like this cylinder, I fill it up with 1 volume of oxygen, 2 volumes of hydrogen, then I put it to a flame, let it explode, and then all of you probably know this, it's a very noisy reaction, and then water gets formed. So this is the reaction of hydrogen and oxygen. And it means that you need 1 volume of oxygen, 2 volumes of hydrogen, and then water gets formed. See, volumes. I'm not talking about weight, no masses, just volume. And you can, of course, you can take, like here, these are beakers of 2 liters. So you can take 2 times 2, that means 4 liters of hydrogen and 2 liters of oxygen. But volume, you could also think of here very tiny beakers. This is only 25 milliliters, 2 volumes and 1 volume. And by this, I try to get the students into the thinking process of how far can you reduce the volume. And then this is just, so to say, what the Greek philosophy also says. It's a point you fix by purpose. You assume that you cannot divide it anymore. That means you think about the challenge of thinking of sort of balancing out the process of dividing, coming to an end, or being able to divide to infinity. This is an idea you think about, is infinity, does the concept of infinity fit to matter? So that's how we get to this point. Next step. So I want to invite you now to follow a specific way of thinking about about how matter interacts, like we have had here with hydrogen and oxygen. I start with solid substances, just like with the stone here and another stone here. So now you see these two stones. Each stone has a certain volume. When you take one stone and put the other stone on top of it, and I would ask you, how much volume do I have now? Volume A here, volume B here on top. How much is the whole volume? Of course, you would say, well, then we have volume A plus volume B. This is the idea when you want to build a house or anything, something like this. We assume that if we add a stone onto another stone, of course, we think then we have two volumes together, added. So it's an addition of volumes. Then you can come to the next idea. Instead of taking stones, now I take two different solid substances. As you can see here, this is wood, and this is salt, sodium chloride, our typical salt we eat each day. So we have two volumes again. If I put the salt crystal here on top of the wood, and of course, what would you say? We have volume A plus volume B, and so we have a whole. The substances don't interact with each other. It's just an addition again, even though we have two different substances now, not the same substance. Now we have two different substances. So much for the solid substances. Now we'll switch to this point here. Now we proceed to liquids. Here I have water, and as you can see, I have 50 milliliters of water, and I measured another 50 milliliters here, and when I add 50 milliliters of water to 50 milliliters of water, of course, then we have 100 milliliters of water, and that's what all of you probably would expect right away. So now we have 100 milliliters. So again, it's an addition. Two different liquids. Two liquids, same substance, same volume, 50 plus 50 adds up to 100. Next step. So again, you see here I have water. And I colored the water a little bit with a specific salt, just with very few crystals, only that you can see the water more clearly. So here we have again 50 milliliters of water, and I add 50 milliliters of oil now, carefully. And as you can see, now we have again 50 plus 50, but we have two different substances. We have water, which stays below, and we have oil, which stays above. They don't mix. They don't react with each other. It's like with the wood and the salt. They don't mix, they don't react, and they add up to 100 milliliters. The very same is true for gases. You could do the very same with gases. Now comes the interesting point. Now I mix two liquids again. I take 50 milliliters of ethanol now and add 50 milliliters of water. And now, it's pretty clear to see. Then now something interesting happens. If you take 50 milliliters of alcohol and 50 milliliters of water, as you can see, they don't add up to 100. It's a little bit less. About 3 to 4 milliliters are missing. It's a little bit less. So at this point, when you follow a phenomenological way, you would say, well, this is quite interesting because when you add two volumes And in many cases, you experience that two volumes just add up with each other. And then you come to a certain point that you find out that two volumes don't add up to one sum. Instead, a little bit is missing. That is interesting because then you can think about what happens in nature. This is what Wilfried touched about with the periphery. You can widen your perspective and you can say, well, what happens all over the world? What do I know about gases and liquids and solid substances? What sort of substances can I mix? What do I experience day by day? Like, for example, here I brought this. Oh, can you see it? Yeah. This is just, as all of you know, when you take a little bit of water and you put CO2, carbon dioxide, to it, and you can put a whole lot of carbon dioxide into it. And as all of you know, the volume does not really expand. The carbon dioxide dissolves in water, so the volume more or less stays. Then another interesting thing here, for example, now what do I do? I take 100 milliliters of water and I add 25 milliliters of salt. Actually, a little bit more because there is some air between the salt grains. And when you see here now, which volume do you have? You have about 125 milliliters. So salt plus water adds up to 125. But here, as you can see, this is what I prepared this afternoon. And when you let it stand for a while and stir it, as you can see, the volume starts to shrink a bit. Now you have a little bit less than 120. So the volume shrinks. First you think, well, we have 125 milliliters, and after a while you see something must happen. This is quite interesting, that here again something happens with salt and water. As you can see, I put some sort of a white substance into this little test tube here, and I add just a little bit of water. So, and yeah, it's just like this now. Now I heat it up. So, as you can see, smoke comes out, whatever it is. And as you also can see here, just in, that the volume here increased. So what do we have? We have, when we mix substances, the volume A plus B can be added. One thing. Also, the volume can be reduced or the volume can be enhanced. So actually, it's very interesting to follow all the line of volume changes. And this is what Wilfried tried to point out with the phenomenological approach. You have a series of reactions, and then you try to think about and how does it make sense? What might be the idea behind it? But now I want to introduce you to the reductionist approach and to see how does the reductionist approach fit to the phenomenological approach. What do public school teachers do in Germany right away? And now please try to follow precisely. And then, Mike, I want to ask you one question now in the end. What do the reductionist teachers do in high school right away. In Germany, this happens in grade 7. They show this experiment, alcohol plus water adds to, or like 50 milliliters plus 50 milliliter add up to 97 something milliliters. So the volume shrinks. How do they explain it? They say, well, the molecule of water is smaller than the molecule of alcohol. And so instead of taking now molecules, because you cannot see that, what they do is, here I have 50 milliliters of chickpea seeds. Ja, ich glaube, das braucht, naja, vielleicht haben wir es dann schnell. 50 milliliters of chickpea seeds and 50 milliliters you could take sesame seeds. In this case, it's chia seeds. So very tiny seeds and very big seeds, sort of trying to show the size of the molecules. They mix it, and of course, and then you shake it. And of course, when you see it, it's quite a bit. It's not 50 plus 50, it's not up to 100, but here in this case, it's a little bit like 85. So there is this volume is reduced. So this is the phenomenon a reductionist or a teacher who teaches in a reductionist way will show to his or her students. Now we change, we go over to the slides. Here. So this again, this just repeats 50 milliliter water plus 50 milliliter adds up to 100 milliliter. 50 plus 50. Alcohol adds up to 100 milliliter alcohol, but 50 milliliter water plus 50 milliliter alcohol adds up to only here 96, 97 milliliters. So there's a lack of volume. How do you explain this now? Next slide, please. When you go right away in grade 7 into reductionism and right away into the atom, you say, well, water has very small atoms and alcohol has very big atoms. I don't know whether it's good enough to see, but here big yellow dots and here tiny blue ones. So you have big, like the chickpea seeds here, and here like the sesame or chia seeds with the water. Now you give those together. Next slide. And now the explanation is, so if molecules of different sizes are mixed, then of course the volume will get reduced. So I wanted to come to this point. Jetzt brauchen wir mich hier wieder irgendwie. Aha, back again. And so I would like to get into the discussion with all of you. And please, of course, feel free to ask all questions which are in your mind. But the question I would like to start the discussion with is, when you think about your idea of the atom, and you think about this experiment here, first with alcohol and water, is it? Alcohol and water. This one. And then with here with the chickpeas and the small seeds. And you recall the explanation from a reductionist point of view. Where is, so to say, the mistake or the gap in this explanation? There is a gap, and this is, I try to work out this with my students, and this is the point how I try to get into the idea of atoms and electrons and so on. There's a gap in this explanation. And if you don't think about it, you will just read it and then learn it in school and then forget it again or so. But when you start thinking about it, this opens up a very interesting point of view. So welcome to the discussion. This would be my question to you, but of course, feel free to ask everything what you want to ask. So much from my side.
Thank you so much. There are already some questions in the chat room. Do you want to address them first, Dirk and Wilfried?
Yeah, what is it?
I can see in the chat two questions at the moment. What was the students' feedback afterwards? And the other is already related to the molecules. I think, Dirk, I will start with this feedback afterwards, and then you can already think about the spiritual relevant explanation of molecules, which might be very challenging. I'm also looking forward to hearing it.
The size of molecules.
Yeah. Okay, let's get started with the students' feedback. I already mentioned that the students had in Kassel in the chemistry main lesson a reductionist approach, and for them that was the popular approach, and the elective was the real scientific approach. That was the way they experienced it. And I think they related to the philosophical realm that was provided in the discussions in the elective, and in the main lesson there were predominantly just reductionist approaches. And the other point what the students mentioned is that they really need support in this hybrid teaching. That means you really need worksheets or you need summaries in order to structure your work. They had time in the lessons to take notes and to write in their books, but soon we realized we really had to offer worksheets, and in the worksheets you have half a page free, and then they can just make a graph or make a mind map or write a brief text. But in a main lesson, in traditional main lesson, I do not offer anything for the silent work within the main lesson. They can just work on their main lesson books in a way that makes sense to the lesson, but they have a lot of freedom, and this freedom is too much in an elective. Did I answer the question, or do you have other question, Graham? Dirk, did they enjoy the course?
Sorry not to speak. Thank you. Yes, did they enjoy it?
Yes, there was the feedback. On one hand, what they said. So what we forgot, in the end, we met here in Kassel. I went with my students from Marburg to Kassel. So at least that at one time, all of the students and teachers were together in one room, and we were all in presence. And we took 1.5 hours only for feedback, for a long feedback session. And they said, on one hand, they enjoyed it very much. That's one thing. On the other hand, they also said it was very demanding for them. It was a completely different sort of teaching they were used to, not only because of the hybrid situation, but also to go so much into details and not to learn for the next test or for the final high school exams and so on, just to and also to discuss so many interesting points and related also to daily life and so on, that there was the feedback. They enjoyed it and also they appreciated it.
And we had just a heterogeneous group, so it wasn't
quite
a group only with people with a special interest in science. It was really heterogeneous, and that was the condition for the school to agree on that pilot project, that you do not pick the highly gifted students for an elective that is a pilot project, that you just take a heterogeneous group like it is, and it worked.
Thank you. Thank you. I'm glad. Thank you.
So I think where's the room in between in fluids, And this is the same with the question, is the size of molecules also the spiritual relevant explanation? So I think that those like Robin and I don't know, Palim, they both picked exactly the right point, because when you look on the chickpeas and the chia seeds, there is space in between, and that space in between is filled by air. And when you use this as an explanation, and you assume that there are molecules and atoms, and there's space between the atoms and the molecules, then this then you have the wrong picture, that there's space between those molecules. But the thing is, there's no air between, there's nothing between those molecules. So you come to the concept of nothingness. And this is fairly new in science, because I assume that many of you grow up with the idea that the whole world is mainly made up and composed out of nothingness. It's just an empty void, because when you look on the size, on the space an atom takes up, many people don't know, like when you look on blackboards, and you probably know that you have, like when you have these formula here, like for alcohol. So first of all, it's not three-dimensional, of course, but then you have very close distances. But when you look onto the findings of scientists, you see that between the nucleus of an atom and the size of the atom, there is a distance of 10 by the power of 5, which means if the nucleus has a diameter of 1 meter, the whole diameter of the atom would be 100 kilometers. And this is what is usually not taught in chemistry. And so when you teach this in grade 7, you only can believe it, but it makes no sense from the modern point of view of quantum mechanics, of the point of view where we got to with modern, like in modern physics and chemistry. This is one thing. And on the other hand, from the spiritual point of view, what is discussed now, this is how chemistry and physics relate to each other. Because the room between the nucleus, this is not an empty space. This is what Wilfried works upon in physics, in the physics part, that of course you can come to the idea of an electron, but electricity, the whole room is filled with electricity, with what is called a field, with waves of energy. And so this is very important from a spiritual point of view, that you come to the power and the idea that there's a whole lot of power of energy in the world. Of course, I might stop here and just ask.
Yes, and I would like to add from a physical point of view, to put it in a nutshell. You just apply the concept of a solid, of a rock, of something really solid, if you argue with those particles here like Dirk did it. And you do not realize that you already apply a context, then especially what is a solid, and you treat the atom like being a solid. So you have some appearances, the appearance of encounter a solid, and you apply it to a microscopic world. That is one point. And the other point is, if you argue this way and you apply agency to those particles and they can make something, then you overlook the point that the atom brings two aspects together, the possibility for and the matter that takes up space. So you have very different aspects, possibility for, matter that takes up space, and mere structure without an underlying matter as a field in the surrounding.
Yeah.
There is another question in the chat.
Yeah, how many times did you try this hybrid experience? And so
This-
now comes our advertisement block. We just tried it out once. And so it was just what Wilfried said in the beginning, just recently, last school year. And yeah, we were already asked to repeat it again. And so we are open for, yeah, let's say invitation, or if you want to join this experiment again or whatever, just feel free to ask us. Our email addresses are in the on the last slide, and since it will be published pretty soon, then you can just ask us, just try to contact us, and yeah, we can figure out. We would be happy to repeat it, but so far we just tried it once. It's just a singular experience.
And our working hypothesis is to offer it next time in English once a week, and to, for example, on a Wednesday afternoon in German time, in local time, so that you have maybe can join in Asia in the early afternoon. And our idea really is once a week, a little bit longer. But what is really important is that students do not attend it by themselves. There has to be a teacher accompanying it.
Yeah.
And at the very beginning, I accompanied it in a way that I just was sitting in the classroom taking notes, and this did not work effectively. And then I decided to take a flip chart and take my notes in a way that everybody could see the way how I structured Dirk's lecture. And then this was some sort of learning pathway, and my learning pathway was translucent for the students, and they had the chance at the same time to see how an experienced teacher takes out knowledge out of Dirk's presentation. And then that was like a striving for them really to make their own notes, to make their own not main lesson book, elective book in a way that fits to them. But without my activity directly beside the screen on the flip chart, it didn't work that well. So you need somebody in the room to make this face-to-face atmosphere. And we got this idea because I have friends teaching at US universities, and they offer some lectures face-to-face, but at the same moment they transmit it to other places around the globe. And then at these remote places, those lectures are always accompanied by very experienced lecturers supporting those students. And that is necessary. That was my experience.
Thank you so much to both of you. I can imagine that, of course, there are many things coming together. One thing, of course, is that you two are experts in your field and have a very high developed sensitivity how to connect natural sciences, which was Sylvie said, which with the connection to the earth and to have a better connection to the surrounding world. And I think this hybrid format, of course, it offers also possibility maybe that should be considered now that has been 2 cities in Germany, but it's easily also to be done between on international level, so that classes from different countries can come together and have the expertise from the people from different countries. That could be a wonderful thing. And what you said in the last part, Wilfried, that you say, of course, the presence of the teachers with the Zoomies, so the people in the Zoom room, this is something quite important for them, because you bridge with your knowledge of Dirk and vice versa, you bridge it for the students. And this is a quite important thing, that it becomes real. It's not just get lost in the digital world. It becomes real by the personality, and especially the last remark that you put your notes in public, so that the students, that you are still something real for them, so to speak. This is really a helping thing. I think it's a wonderful experiment, which is for Waldorf schools where there is a lack of teachers, of course, and especially in natural sciences, maybe to bridge something where we have all of us have problems. And I would be happy if there is more exploration in that field. Thank you so much to Dirk and Wilfried. It was a pleasure to see that performance. It was a real performance. Thank you so much. And I wish you a good day, good night, wherever you are, and especially a good week. And looking forward to see you all again. For me in 2 weeks, but for all of you, hopefully in 1 week. All the best for you.
Bye bye.
Bye bye. Have a good time.
Bye bye. Thank you so much.